Hello students, welcome back to our paper CHO 5403, that is Biomolecules, Organic Chemistry of Drug Design and Chiral Drugs. Friends, in my yesterday's lecture we discussed about amino acids. What are the amino acids? Classification of amino acids, that is polar, non-polar, as well as acidic, basic and neutral amino acids. Then we learned about their pH or the basic acidic and neutral pH of the amino acids. After that we learned about Zwitter ions and so on. So friends, in today's lecture we are going to start with the synthesis of amino acids. So there are three very common methods used for the synthesis of amino acid. That is, first one is STRECKER synthesis, second is modified Gabriel synthesis, or most famously known as Gabriel malonic ester synthesis, and third is Erlenmeyer synthesis. This synthesis we will study. This synthesis we will study for the amino acids. So let's begin with the first synthesis, that is a STRECKER amino acid synthesis. So the STRECKER amino acid synthesis is a method to synthesis of amino acid. In this, there is a reaction between aldehyde with ammonium chloride in presence of potassium cyanide. That means this is a simply a reaction of imine. That means the formation of imine, and then that imine was attacked by the cyanide ion, and then this condensation reaction will yield us the amino nitrile. Okay, this after imine formation and attack of cyanide, there is a formation of amino nitrile. When this amino nitrile is hydrolyzed, it will subsequently gives us the amino acid, or I will say alpha amino acid. Now let's see the its advantages. So by varying this R group from the aldehyde or imine, I will say by varying this R group, we can prepare wide variety of amino acid by this method. So let's see the mechanism of this STRECKER amino acid synthesis. As you know that when ammonia reacts with aldehyde, there is a formation of imine by loss of water. Okay, so after the loss of water we get imine. So that imine was attacked by the Cn minus, as Cn minus is a good nucleophile. It will attack on this and we get the neutralization of this positive charge on the nitrogen. So friends, after that we get the alpha, I will say amino nitrile 3. So this amino nitrile, when in the next step we will hydrolyze it to the amino acids. So let's see the next step. Now we have this 3, that is a amino nitrile. The nitrogen of this nitrile will abstract the proton, and that intermediate is attacked by the water molecule. We get this type of intermediate, which was after proton exchange and another attack of water molecule, we get this diamino diol. Okay, this diamino diol, when heated or treated with the acid, there is a loss of ammonia, and after the loss of ammonia we get the alpha amino acid. So this is the mechanism for the STRECKER amino acid synthesis. So friends, let's see one example. That's why you can easily understand what is meant by STRECKER amino acid synthesis. So in this case we are using ammonia and SCN are the our main reagents. So friends, we are not using ammonia as such or SCN as such. This is a mixture of potassium cyanide and ammonium chloride. So ammonium chloride in presence of potassium cyanide will give us first ammonia, which will convert this aldehyde into imine, and this imine was attacked by the very good nucleophile, that is Cn minus, and we get alpha amino nitrile or amino nitrile. When this alpha amino nitrile, when treated with the H3O plus or simply the acid, we will get the alpha amino acids. So in this case we have started with this aldehyde, we get imine, and after that we get alpha amino acid, and this amino acid is nothing but is a phenylalanine. Okay, this is the phenylalanine, one of the 20 essential amino acids. Okay, so friends, this is how the structure amino acid synthesis help us for the formation of amino acid. So let's see the another synthesis, that is a modified Gabriel synthesis, but very famously known as Gabriel malonic ester synthesis. It is another reaction to produce amino acids. So friends, what is Gabriel synthesis? The very common or the traditional Gabriel synthesis is treatment of this potassium thalamide with the alkyl halides to get the amines. Okay, so we get generally primary amines with the help of Gabriel synthesis. But if we do this modified Gabriel synthesis or Gabriel malonic ester synthesis, we are using, instead of simple alkyl halides, we are using diethyl alpha bromomalonate. Okay, we are using malonic esters. Okay, we are using malonic ester. Alpha bromomalonate is used for this synthesis. Then the attack of this N minus on the alpha carbon, which will subsequently alkylate this thalamide to this compound. Okay, so this alkylated malonate will then have one proton, which is acidic proton, or I will say this is on the active methane group. So this proton is abstracted by the base and it was treated with the RCl, that is alkyl halide, and we get the side chain of that amino acid. So this is how we can modify the side chain of this amino acid. And as you know, the traditional Gabriel synthesis, the thalamide is hydrolyzed with the NaOH or KOH, and then after neutralization we get alpha amino acid in a very high yield, and our side products are this malonic acid and carbon dioxide. This is how the Gabriel malonic ester help us for the formation of alpha amino acids. So the mechanism is same as I told already. This negative charge of the potassium thalamide will attack on the dimethyl bromomalonate, diethyl bromomalonate, and we get this alkylated thalamide, and that alkylated thalamide, when we treated with the base, this base will abstract this red proton, that is, this is a in between two carbonyl groups and very acidic proton, so it will be easily abstracted by the base, and then it was treated with any kind of alkyl halide. Especially we should think about the side chain of alpha amino acid, and this side chain will be introduced in the form of R. So this R is we will get over here, and after that this extra CO2 ET group was removed by hydrolysis, and after that we get alpha amino acid as our final product. So this is how the modified Gabriel synthesis, or simply Gabriel malonic ester synthesis, help us for the formation of alpha amino acids. So in the next lecture we'll discuss about another synthesis, that is Erlenmeyer synthesis of amino acids. For this lecture, if you have any doubt, please feel free to ask me. Thank you.